This video is on the objective plot points using polar coordinates. Alright, so when we plot points on the XY plane, we're used to plotting them in what are called rectangular coordinates. Alright, let me show you really quick. So again, what you're used to is you have a horizontal axis, usually called the x-axis, which is a number line. A vertical axis, usually called the y-axis, another number line. And I mark off some, I'll mark off the integers here. And then you got, positives going up for the y's, negatives going down for the y's, and so on. And when we talk about plotting points in rectangular coordinates, again, these are, this is the typical way we do things, the way we're used to. Say I told you coordinates just tell you how to get to a location from the origin. Right, if I said, what are the coordinates, the rectangular coordinates of this point here? So what you're doing is you're traveling, on a rectangle, starting from the origin. And if I start from the origin, I'd travel to the right, 3 units, and then up 2 units, right? And you see or you could have gone up 2 units and then right 3. And do you see the rectangle here? Right, and this is the ordered pair, 3 on the x-axis, comma, you have an x coordinate, and then 2, it's in line with 2 on the y-axis, you have a y coordinate. Right, and hopefully you can see my little dashed lines here. You're forming, if you look at this thing, it is a rectangle, right? You are traveling on rectangles to describe how to get to a location on the plane. Well, in polar coordinates, we talk about these polar coordinates. Instead of traveling on rectangles from the origin to find a location on the plane, we're going to be traveling on circles that are centered at the origin to find a location on the plane. Right? So let me show you that here. So you see all these circles in this grid, right, centered at the origin. This is called, a polar grid. Alright, so if you want to see more about what they're saying here, about the objective, right, click on More Instruction. In fact, I'll show you a little bit of that instruction, some of their notes. Look at their notes, their examples, their videos. Hopefully those help you. But so again, I'll go over some of the notes here. Plotting points using polar coordinates. So again, I've already mentioned, when we think about plotting points in the plane, we usually think of rectangular coordinates, with an x coordinate and a y coordinate, going left and right and up and down. However, there are other ways of writing a coordinate pair and other types of grid systems. So in this section, we're introduced to polar coordinates. Sometimes polar coordinates are also called circular coordinates, as you can see why, right? The grid, you're traveling on circles centered at the origin to find a location on the plane. Which, are points labeled, now instead of an x coordinate and a y coordinate in your ordered pair, in polar coordinates, you're going to have an r coordinate and a theta coordinate. R will basically describe to you the radius of the circle that you're on, and theta is the measure of the central angle that you sweep out to travel to your location. You'll see what I mean by that in some pictures in a minute, and are plotted on a polar grid. As you can, here's an example of a polar grid. Right? Circles instead of rectangles. The polar grid is represented as a series of concentric circles, right? Circles with the same center, radiating out from the pole or the origin of the coordinate plane, right? So in polar coordinates, the origin is now called the pole. I might still just keep calling it the origin. All right, the polar grid is scaled as the unit circle with the positive x-axis now viewed as the polar axis and the origin as the pole. Right. The first coordinate r is the radius or length of the directed line segment from the pole. The angle theta, measured in radians, indicates the direction of r. So we move, counterclockwise from the polar axis by an angle of theta and measure a directed line segment in the length of r in the direction of theta. Even though we measure theta first and then r, the polar point is written with the r coordinate first. Right, for example, to plot the point 2 pi over 4, we would move pi over 4 units in the counterclockwise direction and then a length of 2 from the pole. And I'll actually draw that out as an example. And they said, you can do theta first and then r. I'm saying you can do both. All right, I'll show you both. All right, so I'm pulling up a piece of paper here again. And now I'm looking at, instead of the rectangular coordinate system, doing the polar coordinate system. So this is polar coordinates. And again, think of this as two number lines, 0, and again, instead of traveling on rectangles, if I want to create this polar grid, right, we're going to be traveling on circles centered at this pole here, right? The origin is now called the pole. So here's a circle of radius 1. Here's a circle of radius 2 centered at the pole. A circle of radius 3, and so on. So when we move to certain locations, right, we're going to be traveling on these circles. And you could also have circles of radius 1.5 or 0.2. The radius could be any length. Now they're telling you here again, this horizontal axis, instead of being called the x-axis, we can call it now the polar axis. Right. So if I give you coordinates and ask you to plot a point in polar, right, their example was this, r comma theta. Right, again, the first coordinate is a value of r, like a radius, and theta is an angle. If they said, measure r theta equals, the 2 for r, and pi over 4 radians, which was 45 degrees for theta. If I was asked to plot this point, so what I'm going to do is the way they suggested it is I draw the angle in standard position. So remember the angle, how you draw angles in standard position. So when we start, here's the positive, polar axis, right? The positive polar axis. And really, I'm just going to tell you to plot points. What we're going to be doing is rotating I'm going to think about rotating the whole polar axis by an angle of theta. I'll rotate the entire polar axis, this horizontal axis, by an angle of theta. All right. So what was pi over 4? Well, remember that was 45 degrees. So here's pi over 4 radian, and it's in the counterclockwise direction. Remember, positive angles were swept out in a counterclockwise direction. If you're ever given a negative value for theta, you'd sweep it out in a clockwise direction. So sweeping out a pi over 4 radian angle takes me here. Now again, imagine this is the entire polar axis again. So here's the polar axis rotated pi over 4 radians, right? So if I did that, here's 0, and then here's one unit, a radius of positive 1, radius of positive 2, radius of positive 3, and so on. You'll also see, though, we're going to get values of r that are negative. So if I wanted to locate the point with a radius of negative 1 here, there's a radius of negative 1, radius of negative 2, radius of negative 3, right? Just being on these circles. And then the point they want. So I rotated the horizontal axis by pi over 4 radians, and then I just locate the point that's corresponding to positive 2 on the polar axis. That's 2 units away from the origin. So that would be this point right there. There's the point with r is 2, theta is pi over 4. Okay. All right. So again, so rotate polar axis by theta, and then locate corresponding value of r. All right. Now that is one way to do it. Another way is you could do r first. Just go to r equals 2 on the polar axis. So here's r equals 2. And then from that point, you travel on a circle, and sweep out an angle of positive pi over 4, which would be going counterclockwise. So I go to 2 on the positive r axis here, polar axis, sweep out an angle of pi over 4 radians that's going counterclockwise, pi over 4 radians, 45 degrees on this circle, and then I end up here at the same exact point. So you can think of it either way. You can do theta first and then locate r, or you can locate r first and then from that point do theta, right? Sweep out an angle of theta on some circle. Okay. Alright, so they show this example right here. Alright, so what if I asked you to do this? Alright, I'll do another one. I'm going to do a couple of examples in this. So back to my paper, what about this point here? What about r theta equals 3 pi over 2? So again, there are a couple ways you can do this. So one way is to sweep out theta first. Take the polar axis here, and then theta is positive pi over 2. So rotate the polar axis positive pi over 2. So that's, again, starting from here, going all the way to the, so it'd basically be lining up the polar axis with this vertical axis. Right? And then locate positive 3 on this vertical axis. Right, so that'd be this point right here. There's the point with a value of r of 3, a radius of 3, and a value of theta of pi over 2, or 90 degrees. And again, you could also have done this. Locate r first on the horizontal axis, the polar axis. So r is 3. So I go to where 3 is. So I start here, and then sweep out an angle of positive pi over 2. So I'm going counterclockwise on this circle, pi over 2 radians, and I would end up here at that, value 3 units away from the pole on that vertical axis. There's the point 3 comma pi over 2 in polar. Alright, so hopefully this is pretty simple. Now again, you're going to see some cases where you have negative values of r and negative angles. So they might get to some examples like that, like here, right? So what if I was asked to plot the point negative 2 pi over 6 on a polar grid? Alright, so I'll draw a new polar grid and come back when I'm done drawing it. Okay, so here's another polar grid. Right, again, very rough sketches on my part, but we have these concentric circles, right, with all the centers of these circles being at the pole, at the origin. We have our horizontal, polar axis, just a number line. Alright, and then they're asking me to graph, plot the point r comma theta equals negative 2 comma pi over 6, positive pi over 6. Alright, so again, I can do the theta first if I wish. So I'm just going to rotate the polar axis positive pi over 6 radians. Alright, so that'd be 30 degrees counterclockwise. So let's say that's this here. And I'll draw this, so I'll dash the line in. Continue it over here as well. So again, imagine this is the polar axis rotated, positive pi over 6 radians. And then on this line here, this the new polar axis, where the polar axis rotated to, I'm locating the value of r equals negative 2. Right? So basically, where would negative 2 have gone? Right? Negative 2 was here. If I rotated this pi over 6, I'm landing here. So I'm at this location then. On this circle with a radius of 2, here's where negative 2 would have gone if I rotated the polar axis, the whole polar axis, pi over 6 radians in the positive direction, the counterclockwise direction. So there's the point with, negative 2 comma pi over 6 in polar. Now they may also ask for, locations with negative angles. I don't think they're doing that here, but just remember that negative angles, I'll do one example on this. What if I wanted this location, r theta equals, I guess I should have written this in here, this is positive pi over 6 rotation here. What if I wanted this, What if r were positive, say 3, but I had a negative value for theta, like negative pi over 4? So it's the same procedure, right? Same procedure. I'm going to rotate, again, the polar axis, take this horizontal number line, rotate the polar axis by an angle of negative pi over 4. Now hopefully you recall that negative pi over 4 is in the clockwise direction. So again, starting from here, the positive polar axis going negative pi over 4 is going clockwise 45 degrees. So I'm like this. And then here's what, this is like the new imagine what the polar axis did, right? So again, this is a rotation of the polar axis by negative pi over 4 radians clockwise. And then r is 3, positive 3. So I locate where would positive 3 have gone? It would have gone here. And again, I'm going to be on this circle of radius 3. All right. So there's the point 3 comma, negative pi over 4. But also, I could also on this line here, this new polar axis, I could have also located negative 3 comma negative pi over 4. That would be this location over here, just on the opposite side of the circle. All right, this is where negative 3 would have gone if I rotate pi over 4 radians clockwise, right? Go negative pi over 4. So this point up here on this circle is the point with r equals negative 3 and theta equals negative pi over 4. Right? So you can find any location, any location on the plane can be described, in polar coordinates. You can describe how to travel to that point. Right? Okay, so that's their instruction, at least part of it anyway. That's some of the notes. Now let's just get into this question here. They're asking, what are the polar coordinates of this point shown below? Now you see what they've done here. In a lot of these polar grids, they'll have these other lines drawn in through here. So you have this polar axis, the horizontal axis. Then the vertical axis corresponds to rotating 90 degrees, right? Or 270 degrees. Then you have this line here, which basically corresponds to rotating 30 degrees or pi over 6. Then you have the 45 degree line, the 60 degree line, and again the 90 degree line, and that's in that's all these lines here. So here, this is, this point Q. You see this is on the circle of radius 5. So the r could be 5 or negative 5 depending on what angle you sweep out. Now I'm on this circle of radius 5. Now there are a couple ways to get here. Right? There are actually infinitely many polar coordinates for any given point, because you can just keep adding 2 pi or subtracting 2 pi, and then it'll take you all the way around the circle again and land you right back at that point. So I could do this. I could go r for 5. R is 5, and then I would travel. This is clockwise to get to Q, so a negative angle, that'd be negative pi over 6. So positive 5 for r, and then negative pi over 6 for the angle, for theta. Or if I add 2 pi to this, go positive 5 for r, and then that's all the way around to 11 pi over 6. Or I could have gone to negative 5 for r, and then traveled counterclockwise 5 pi over 6. So negative 5 for r, and then 5 pi over 6 for theta. Or negative 5 for r, and then travel clockwise, go negative 7 pi over 6 for theta. There's lots of different ways to get to point Q. So of these, again, 5 and negative 11 pi over 6, that wouldn't work. Again, 5, negative 11 pi over 6 would be going clockwise, and you end up here. 5, 4 pi over 3, no. Yeah, 5, 11 pi over 6 was one of those I said, right? I start at 5 on the r, and then go positive 11 pi over 6 on this circle. I would land at Q. So it's this point here. And hopefully you've seen me do those few examples earlier. Showed you how to do this, right? So again, it's 5 for r, and then you're on this circle with a radius of 5. And if you travel, counterclockwise, you're doing a positive angle. If you travel clockwise, you're doing a negative angle. Simple as that. All right, wonderful. All right, so hopefully watching me go over this, explain a few things, looking at the more instruction if necessary, reading the answer explanations when they come up. Right? I'm hoping that all this stuff helps you when you work on this material on your own. And thank you very much for watching.